So probability is our new unit on page 43, which is this blank page. Okay, so some things that you have to know, and they're assuming you know, and hopefully you will know most of this. First thing is the alphabet. Okay, how many letters are in the alphabet? Oh, your language arts teachers are going to be disappointed. 26. Okay, there are 26 letters in the alphabet. Okay, there's two different types of letters in the alphabet. Can anybody tell me one of them?
Lowercase and uppercase.
Okay, so there are lowercase and uppercase, but there's also
Vowels.
vowels. Okay, there are 5 vowels. If you didn't know, they're A, E, I, O, U. Now, sometimes Y does not count in probability. Okay, probability never counts the Y's. Okay, what are the other letters that are not vowels called? Starts with the C. Yikes, Miss Fivery. They're consonants. So there are 21 of them. All the other letters. You will see those words and you have to know what they mean. Okay? Vowels, A, E, I, O, U. Consonant is everything else. We're on page 43. It is the blank page right behind the word probability. All right, so that's the first section that they are expecting you to know. Okay? Another word we're going to see a lot is a numbered cube. Okay? This is a fancy word for a dice. Okay? They don't like to use the word dice, I was told, because they don't want you to associate this with gambling. Okay? Even though we use dice in all kinds of games, they don't use the word dice, they use numbered cube. Just know that it's a number dice. Okay? There are the numbers 1 through 6. There are 6 numbers. And it's 1, 2, 3, 4, 5, 6. A lot of times they ask you about odd versus even. Okay, how many odd numbers are on a dice? 3. I think because I told y'all this is being recorded, y'all are scared to talk. Okay, there's 3 odd numbers. And then that means there's also 3 what? Even, thank you. Okay, 3 odd numbers, 3 even. Again, if you don't remember or didn't remember, odds are 1, 3, 5. Evens are 2, 4, 6. Okay, you will be expected to know odd versus even. All right, the next one, hopefully everybody knows everything about coins. Okay, a coin, there are 2 things that could happen. I could get head or I could get tail. Nothing else could happen on a coin. I could get heads or I could get tails. The last one, and this is the one you may not know everything, so this one might be new. Okay, cards. In a deck of cards, how many cards are there total? Anybody know? It's okay to be wrong. Yes, thank you, Kate. Has anybody ever heard of the game 52 card pickup? That's where you throw all the cards on the floor and you have to pick them up. Don't play that game with someone. Okay, it's a trick. There are 52 total cards. Okay. Whoops, I spelled total wrong. Now, within cards, there are several different things. Okay. Cards are usually made up of colors. And there are usually 2 colors. It's usually red or black. Sometimes it's blue or black. Okay. But red is usually one of the colors and then black. Okay. We also have these things called suits. Not like clothes, but suits of cards. Okay. There are 4 suits. They are diamond, heart, spades, And I am not an artist, so please don't judge me here with this beautiful artwork and clubs. Okay? So diamond, heart, spade, and a club. I'll give you a second. Okay? Diamond, heart, club, and spade. Again, they're assuming that you have seen a deck of cards, you've played games, that you know what all these different things are. Diamonds, hearts, spades, and clubs. And there's one last thing we need to write. But I still see people here writing, so I'm going to assume at home you're probably writing too. I'll give y'all just a second. All right, and then the last thing is numbers. There are numbers on cards, okay? There are 13 different numbers, okay? It goes from 2 all the way to 10. And then you also have a jack, a queen, a king, and the ace. Okay? So those are all the things that are in a deck of cards. All right, you can turn to the next page, and now we're going to start with sample space. Okay, sample space is super easy. Okay, there's not really any math with sample space. Okay, also let me draw your attention to page 40. Page 40. On the test, there's going to be a vocab section of your test. If you get to use your notes, and I have all the vocab right here on page 40, and you miss them, I'm going to be very sad. Okay? Make sure you use your resources. Page 40, probability vocab. Make sure you know that it's there on the test day. Okay? All right, here we go. Sample space. Okay, sample space is all of the possible outcomes of an event. Okay? Everything that could happen. If I was to flip a coin, what could happen?
Heads or tails?
I could get a head or I could get a tail. Okay? On the spinner, what could happen?
It could land on one of the colors.
Yep, it could be blue, red, yellow, or green. Could I land on purple? Could I land on white? No. Okay, so this is the sample space. It's everything that can happen. It is shown with lists, tables, and tree diagrams to determine the probability of a simple event. Simple means 1, and compound means 2. Okay? Now, the next thing says the New England Patriots and the Cowboys are playing. Who could win the game? Okay? Could anybody else win the game other than the Patriots or the Cowboys? No. So, the sample space would be Patriots win or Cowboys win. Could there be a tie in football? Do they ever end in a tie? No. Yeah, they play overtime. So the Cowboys could win or the Patriots could win. Nothing else could happen. Okay? I couldn't say the Broncos are going to come in and win because they're not even playing. Couldn't say that they're going to tie because football doesn't end in a tie. They play overtime. Okay? So that's the sample space. It's really that easy. All right, a numbered cube. Again, this is a numbered cube. What could happen? What could I land on? Yep, any number between 1 and 6. This is the sample space, 1 through 6. Okay? Now, I can land on a 4. I can land on a 6. I can land on a 1. Only these numbers could I land on. Okay? So those are simple events. Looking at a football game, rolling a dice. It's one event. Okay? So we're going to look at what to do when you have two events. Okay, the first one wants us to make a list or a table. For breakfast, Jamie can choose if she wants cereal, eggs, or muffins. Okay, so she has a food option. She can also drink coffee, orange juice, or milk. So she has a drink option. What are all the possible outcomes? Okay, so I want to know not what you would pick, but what is everything that could happen. So if I picked cereal, what could I drink with cereal? Milk. Okay. If I pick cereal, what else could I drink?
Orange juice.
Orange juice. If I pick cereal, what else could I pick?
Coffee.
Coffee. This little line just means repeat, the same as above. Okay? So cereal and milk, cereal and OJ, cereal and coffee. Is that all the outcomes that could happen? Could anything else happen? Do I have to pick cereal? No, what else could I pick? I could pick eggs.
Eggs or muffins.
Okay, eggs and milk. I could pick eggs and OJ. I could pick eggs and coffee. Right. Is that all the things that could happen? No, I could still pick muffins. Okay? Muffin and milk. M&M sounds real good. Not to me. I could pick muffins and OJ. And I could pick muffins and coffee. So those are all the things that could happen. The next question says, how many outcomes are there? So how many total different things could happen? How many things could happen?
9.
9, yep. So there are 9 possible outcomes. Okay? Now I'm going to show you something that makes it a little bit easier. It's called the counting principle, and you're going to have to do this on your assignment. So make sure that you write this. The counting principle. It's super easy. You count the number of options for each category, and then you multiply them. Okay? Super, super easy. So my first category was food. How many options for food did I have? 3. Okay. My next were all drinks. How many options for drinks did I have?
3.
Orange juice, milk, coffee, 3. So it equals 9. When I listed them, did I get 9? Yes. Okay. So if it wants you to make a list, you have to write them out. If it just wants to know how many, don't write it out. Just do the counting principle. Okay. All right. At registration, a student can select Spanish or German, and then they can pick either art, music, or theaters. What are all the outcomes? So if I pick Spanish, what else can I pick?
German.
Okay, it says or German. So my language is Spanish. What's my fine art? Art. I could also pick Spanish and music.
Music.
I could also pick Spanish and
Theater.
Okay, is that all the options? No, because I don't have to pick Spanish. I can also pick German. I could pick German and art. I could pick German and music. I could pick German and theater. So the question says, how many total outcomes are there?
6.
There are 6. Again, I can just count. But if it just asked me how many and it didn't want me to list, I'm not going to count. I'm going to say, okay, for language, I have how many options? 2. For fine arts, how many options do I have? 3. 2 times 3 is 6. So So that's the counting principle. All right, a tree diagram. Okay, tree diagram is going to have branches. And this tree diagram says I am tossing a coin how many times? 3 times. Okay, so the first time I toss a coin, what could happen? Heads or tails. Okay, so I'm going to put a little 1 here so I know that's the first coin. Sorry. Heads and tails. And I need to give myself some room because tree diagrams get a little big. Okay, so if this first coin landed on heads, what could the second coin be?
Either one of them.
It could be heads or it could be tails, right? Everybody okay so far? This first one is just the first coin. Now, what if I got tails on the first coin? What could the second coin be? Heads or tails? A coin can't be anything else but heads or tails. That's it. Okay? So here, what if I have heads and heads? My third coin could be what? Heads or tails. Okay? If it was heads, tails, what could this coin be?
Heads or tails.
Are y'all seeing a pattern? The only thing a coin can be is heads or tails. That's it. Okay? So this is a tree diagram. It has the branches to show you the different options. All right? If I asked you how many outcomes are there, the first coin, how many things could happen? Heads or tails. The second coin, what could happen? Heads or tails. The third coin, what could happen?
Heads or tails.
2 times 2 times 2 is what? 8. Good.
8.
And if you go through and count, the bottom, 1, 2, 3, 4, 5, 6, 7, 8. That's it. Okay? So, the way you read this is heads, 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 tails. Heads, tails, heads, heads, tails, tails. This is easier than making a list. Okay, a tree diagram is just a little bit easier than making a list when you have a lot of things. Does that make sense? Okay, you will have, if you come to school on Star Day, you will have a tree diagram on the test, I promise you. They always put 1 on there. Okay, next question, next page. All right, create a list. And will you read that for me? I'm going to go adjust the air because it's hot in here.
Amanda will roll a number and flip a coin. If Amanda rolls the number cube once and flips the coin once, then what are the possible outcomes in which number 2 lands on an odd number?
Okay, perfect. Thank you. All right, this one, we're only wanting to land on a what? Odd number. Okay, this time we have a cube and a coin. Okay, so it says to make a list. So am I going to list 1 through 6?
No.
No, I'm only looking for what kind of numbers?
Odd numbers.
So I could get a 1. If I got a 1, what could this coin be? Heads. Or I could be 1 tails. Does everybody agree? Okay. What's the next number that I could roll on here?
3.
Okay, I could get 3 heads and 3 tails. What's the last one? 5 heads and 5 tails. So I couldn't get a 2-tail or a 6-tail because it has to be odds and the coin. So how many different things are there that could happen? 6. Yep. Everybody okay with that? All right. 2 spinners are spun. What are all the possible outcomes? So on this one, I want to show you how to do a Punnett square because to me, Punnett squares are a little bit easier. You did these in science. It just keeps your list organized. So on my big one, I could get a 1 or a 2. On the small one, I could get a yellow. I could get a red. I could get an orange, or I could get a blue. Okay, do y'all remember doing dominant and recessive in Punnett squares in science? Okay, it's the same thing. So I could get a 1 yellow or a 2 yellow. I could get a 1 red or a 2 red. I could get a 1 orange or a 2 orange. I could get a 1 blue or a 2 blue. Okay, that's just another way to show how to make lists. You don't have to do it this way. I just want to show you another way if you don't like doing this. This makes sure you don't miss anything. Okay. How many options are there? 8. And again, 2 times 4 is 8. Okay. All right, we're going to do 2 more tree diagrams. A clothing line has shirts in red, blue, or white. The pants are in gray or khaki. How many different combinations could be made? Okay. Well, let's do the counting principle first, and then let's check. How many options do I have for shirts?
3.
3. How many options do I have for pants?
2.
And then what do I do with these numbers?
You multiply them?
Yeah. So I should have 6 if I do it right. Okay. All right. So we're going to do this tree diagram up and down because I want to show you that it can go both ways. My first category is shirts. So you list all your shirt options. Red, blue, white. Okay, those are my shirts. Now, if I choose a red shirt because I'm going to go work at Target, what are my pant options?
Gray or khaki?
Gray and khaki. If I pick a red shirt, I can't wear anything else. It's red, khaki, red, gray. Okay, if I pick a blue shirt, what are my options?
Gray or khaki?
Gray and khaki. Khaki's such a weird word. And then if I pick a white shirt, gray and khaki. So again, you read it the same way. Red, khaki, red, gray. Blue, khaki, white, gray, white, khaki. You just read it from the start and you go out to the end branches. And are there 6 of them? 1, 2, 3, 4, 5, 6? Yes. Okay. All right, last one. We're buying a car. Esther is going to pick either 2 or 4 doors. So my first category is doors. And there's 2 options. I can pick 2-door or 4-door. My next option is leather or cloth. Okay, so we'll say inside is leather or cloth. How many options is that?
2.
2. And then the final category is black, silver, or white. So those are colors. How many colors are there?
3.
3. Okay, so how many total different options should there be?
12.
12. Okay, but this one wants us to make a tree diagram, so we need to do a tree diagram. Okay. All right, so first is my doors. My options are 2 and 4. Okay, if I get a 2-door, what are my options for the inside?
Leather or cloth?
Leather or cloth. If I get a 4-door, what are my options?
Leather or cloth?
Yeah, I should have moved my 4 over here. Okay. Now I'm not done because now I have to do the color. Okay, if I get 2-door leather, what are my color options?
Black, silver, or white?
Okay, black, silver, white. If I get a 2-door cloth, what are my color options?
Black, silver, or white?
Black, silver, white. If I get a 4-door leather, what are my options?
Black, silver, or white?
Good. And a 4-door cloth?
Black, silver, or white?
Good. And then again, you can count the branches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's what it's supposed to be, so I got it right. Everybody okay? All right. Now we're going to talk about some simple probability. So go ahead and turn the next page. And we're doing good on time. We should still have plenty of time for you to finish your assignment. Your assignment's pretty easy today. Okay. All right. Simple probability is the chance that something's going to happen. What are the chances that I make the basketball team? What are the chances that it's going to rain today? What are the chances the team that I pick is going to win the Super Bowl? So it's all about chance. Okay, and it's a number between 0 and 1. Between 0 and 1. All right, so one of the big ways that they will test you is making sure you know what word describes it. So if something, let's just start in the middle. Okay, what are the chances I flip a tilt? 1/2, right? 1/2. Okay, so this is going to be equally likely. I am equally likely to pick heads as I am tails. Okay. Now, if we were talking about the people in this Google Meet or in this classroom, okay, is it equally likely that I'm going to pick a boy or a girl? No, because there would have to be exactly half, okay, and we don't have half. In person, I have more boys, and then I don't know what we have as a group here, but it's not half. It's not the same, okay. All right. What are the chances that the Dallas Cowboys are going to win the Super Bowl this weekend? Do they have any chance of winning the Super Bowl? No, because they're not playing. It's 0. It's impossible. Okay, it's impossible. And then what are the chances that tomorrow is going to be Wednesday? It's going to happen. So the word is certain. Okay? There's no way that tomorrow cannot be Wednesday. It has to be Wednesday. So those are the two extremes, and then right in the middle. Okay? Now, if I had these markers, and I said, what are the chances of me getting a green marker? What are the chances of me getting green? 3 out of 4. Okay? 3 out of 4 means likely. Okay? It could happen. There's a good chance it's going to happen. Okay? Is it going to happen every time? No, because then it would be certain. Okay? What are the chances of me getting an orange marker?
Unlikely.
Unlikely. Good. 1/4. Unlikely. Okay? What are the chances of you never practicing, never picking up a basketball in your life, and then walking onto the court and making the basketball team? Very, very, very unlikely. Some people are just born with natural skill, but for the most part, if you've never picked up a basketball, you're not going to make it. That's unlikely, okay? What are the chances if you study, you do all the homework, you use all your notes on your test, that you pass? It's very likely, okay? If you've done everything, it is very likely. So that's what we're talking about, is how likely something is to happen, okay? So we're going to write those words here that match. So snowing if it's 40 degrees outside. Yeah, it's unlikely. It has happened. It has happened. It's very unlikely though, okay? Now it has to be 32 degrees for it to stick, but it can snow when it's more than 32. It's just unlikely, okay? If you've ever lived in snow, you know that it can snow and not be that cold, okay? All right, burning your dinner if you cook it too long. Okay, it is very likely. Okay, it's very likely. Now, is there a difference in cooking it 30 seconds too long and 5 minutes too long? Yeah, an hour too long? Yeah, okay. And it also depends on the meal. Some things you can cook a little longer, some things you can't. Like pizza, depends on your crust. So it's likely that if you cook it too long, it's probably burnt. All right, water boiling at 75 degrees. This is impossible. Okay, the boiling water temperature water is 212 degrees. Is that anywhere near 75 degrees? Okay, that would mean like outside when it's a nice day and it's not even hot, that water's going to boil. Okay, that's never going to happen. It has to be 212 degrees. All right, getting a ticket if you are speeding. Yes, it is likely. Thank goodness it's not certain, because I would probably be in jail because I just have a heavy foot. Okay, the more you speed, obviously, the more likely you are to get caught. The faster you're going, the more likely you are to get caught. But it's likely, and I would probably say very likely. Okay, all right. In football, if you make a safety, what are the chances you're going to get 2 points added to your score? If you don't know football, that's okay. How much is a safety worth? Is it worth 3 or 2? 2, okay? Now, you hardly ever see a safety in a football game, but if you do, you're always going to get 2 points, okay? A safety is worth 2 points, so this one is certain. And then finally, a coin landing on heads. Equally likely, good. Okay. You might see these questions again, so make sure that you have them and you have the right answers. All right, let's talk about actually finding the probability now. Simple probability is the ratio. Remember, ratio is a comparison of numbers, and we're comparing favorable to total. Favorable to total. So if I asked you, and when you see questions a lot, it's just going to say P, parentheses, and then the event, okay? So if I said, what's the probability of getting a green marker? Okay, favorable, there's 3 things that could get picked. 5 is the total. So I'm going to put green over total because I want you to remember the words. It's 3 over 5. Okay, that's all there is to probability. Okay, what's the probability of getting red? 1 out of 4. What's the probability of getting blue? All right. So now the opposite is going to be complement. Okay, not like, oh, Miss Davis, you look so great today. Okay, complement is the probability of something not happening. Okay, so here we said the probability of getting green. You have to look very, very, very closely, and on the assignment there's going to be a couple of these. Do you see the little apostrophe right by the P? Okay, you have to look super close. When you see that word, you need to think not. Okay, so because we said total there, green here, we're going to stay with green. So when you see that little mark, it means not green, not blue, whatever the question is, not. Okay, so same thing. How many are not green? 2 out of 5. Okay, so the complement is this little mark. It's called P prime. The probability of not getting a green. Okay, now this last blank, it says the event, the probability of an event and its complement have a sum of 1. So like 3/5 was the probability. The complement was 2/5. That equals 5/5, which equals 1. Okay, so the complement adds up to 1. All right, now we're just going to do a little practice of finding the probability. Again, all we're doing is counting. That's all we're doing. Okay? So, there's 5 marbles here. What is the probability of picking stripes? 1 out of 5 because one marble has stripes. Okay? Now look very closely. This one has P prime. What does that little prime mean? Yep. So I think of the total. I mean, I put the word not when I see it. So this time it's wanting not diamonds. Okay? This has diamonds and this has diamonds. So how many do not have diamonds? 3 out of 5. Okay. On the next one, what's the probability of getting a W?
1 out of 7.
1 out of 7. Good. The next one has that P prime. What does that prime mean? Okay, not a vowel. So I'm going to take out the vowels. A and A. How many are not vowels?
5 of them.
5 out of how many total?
7.
7. Okay, it's really this easy. Okay, we're going to do a little bit more practice, and then I'm going to let you work on your assignment. Okay. All right, turn to the next page. The only thing you need to remember about these fractions is that we have to always simplify. Remember, simplify means to make smaller. Always simplify. We're always simplifying. All right, so we're starting with the dice. You have to remember that 1 through 6 are your numbers. You won't always need to write this out, but I just want to remind you the numbers 1 through 6. Okay? So it wants to know the probability of getting a 6. How many 6s are there on a dice? 1, 6. Okay? What about the probability of getting a 5? 1 out of 6. What about the probability of getting an odd number? Which equals what?
3 out of 6.
1/2. Okay, again, that's because 3 of these numbers were odd. 3 out of 6 equals 1/2. Okay? All right, we're going to go down. What is the probability of getting not a 6? So I take out the 6. How many options are left?
6 out of 7.
Very good. 6 out of 7. Okay. The next one, what's the probability? Now, we haven't seen the word or yet. Okay, or means to add them. Okay, so a 3 or a 4. So how many numbers are 3 or 4s? 2 out of what?
7.
Out of 7. Yeah, our total is still the same. And then finally, an odd number.
4 out of 7.
4 out of 7. Good, thank you. 4 out of 7. 1, 3, 5, and 7 were our odd numbers. So there's 4 out of 7. Okay? All right, at a pediatrician's office. You might know what a pediatrician is? What is it? Yeah. It's a doctor for children's. Yep. Thank you. Both of my 2 people. I saw the chat and in person. Thank y'all. Okay, so they have 12 puzzles. They have 16 crayons. And they have 2 bouncy balls. Okay, so what is the probability of getting anything but a bouncy ball? So that's just another way of saying not a bouncy ball. Well, how many are not bouncy balls?
28 out of 30.
28. Now, it does not give you the total, but if it's a word problem and they don't give you the total, you have to have the total. Okay? Now, 28 over 30 is even, which means they can be divided by 2. So I have 14 15ths. Everybody okay with that? All right, next. What's the probability of getting a box of crayons?
16 out of 30.
Okay, and those are even, so they can be divided by 2. I'm going to get 8/15. And finally, the probability of getting a puzzle.
12 out of 3, which is 6/15.
Okay, 6/15. But this one can be simplified one more time. Divide by 3. And you get 2/5. So here you could have divided by 4 to start with to get a bigger answer. Or you could have divided by 6. But you get down to 2/5. So just make sure you simplify 2/5. All right, everybody good? All right, let's go to the top. We have a laundry basket. We have all these different socks. Okay, we have 24 total. There are 6 navy, 10 black, and the remaining are white. 6 navy, 10 black. Oops, I don't know how many white, but I know the total is 24. Okay. All right, so the first question says black. Do we know how many black socks? 10 out of
24.
We simplify to 5/12. Okay, the next one says white socks, but I don't know how many are white. What can I do?
You can subtract them.
24 minus 6.
Yep, 24 minus 16 is 8. So this is 8/24. Think of the biggest number you can divide by. Hopefully 8. When you simplify, what do you get? 1/3. Okay? You could start at 2, and then you would have got 4/12, and then you would have divided by 2, and you would have got 2/6, and then you would have got 1/3. So try to think of the biggest number you can simplify first. All right, last one. Navy. 6/24. Divide by 2, yes. Divide by 3, yes. Divide by 6, even better. What do I get? 1/4.
1/4.
Yep. Good, thank you. All right. Moving along, we're almost done. The letters in the word soccer are put into a bag. What is the probability of picking a vowel? Well, which one of these letters are vowels here?
O and E.
Okay, so how many is that?
2.
Out of how many total?
6.
Which equals?
1/3.
1/3. Good. All right. My next one says a consonant. A consonant is everything that's not a vowel. So that's 1, 2, 3, 4 out of 6, which equals
2/3.
2/3. And then finally, the letter C. How many C's are there?
2.
2. And I already did that one. I know it's 1/3. So these are all the different things that they could ask you that you could find the probability of. All right, almost done. You have a movie drawer. There are 7 action, 5 comedy, and 3 drama. What's the probability of picking a drama? How many are drama? 3 out of what?
15.
Good. Which simplifies to be 1/5. Okay. The next one says anything but a comedy. So I take away the comedy. 10 out of 15. Good. Which equals 2/3. And then my final one is action. How many action are there?
7.
Out of?
7.
Which simplifies to? Nothing. So that is how you find the probability. Again, super, super, super easy. The hardest thing is remembering to simplify. Okay? We're going to do this last question. That's going to talk about twice as likely, half as likely. So it says, students were surveyed about their favorite meal. This is the response. Okay? Students' favorite meal is half as likely to be pizza than spaghetti. Well, what's pizza?
26.
What's spaghetti?
8.
Is 26 half of 8?
No.
Not in any world I know about. Okay, the next one. Favorite meal, it's more likely to be fajitas than pizza. Fajitas is 16. Pizza is 26. It's saying 16 is more than 26.
That's not true.
Not true. Okay. Twice as likely to be spaghetti than pizza. Spaghetti is 8. Pizza is 26. Is that twice? Twice means times 2. No. Okay. Twice means times 2. Fajitas than spaghetti. Fajitas is 16. Spaghetti is 8. Is 16 twice 8? Yeah. Okay. And that is all. Okay. Remember to simplify those